is how many degrees? 360. Okay. And half of rotation is 180. So when we're dealing with revolutions, that's one full turn around a circle. We'll review that when we get to that tomorrow, like when we do some word problems. Radians. Radian, actually the definition, I don't know if you know this, but 1 radian is defined to be the angle at the center of a circle which spans an arc of length equal to the radius. What does that mean? That means if you have a circle, and let's say that had a length of x, and this curved piece also has a length of x, that is what the definition of 1 radian is, okay? So radian is a different way that we measure angles. We're going to start kind of shifting towards that in this class. We're going to kind of try to shift from that degree mindset to radian mindset. And so when we're doing that, thanks, Brayden. Take that out of your ear, please. When we're doing that, we're going to keep in mind that pi radians is the equivalent of 180 degrees, which means 2 pi radians is the equivalent of 360 degrees. Okay, and these are in radians. Pi is about what? 3.14, but we're going to leave it in terms of pi. Okay. So about 3.14 of these things is equal to 180 degrees, and about 6.28 of these things, 1 radian, remember, is defined by that. So that's where that comes from. It's not just like radians just existed out of the air. There is a definition for what a radian is. For what we do, we're going to mostly talk about in this chapter rotation angles, okay? And so we're going to have angles that start at a spot and then end at a spot. And so when we're doing that, we have something called standard position. And what happens is for degree angles or revolutions, we're going to draw the angle with their initial side along the positive x-axis of the coordinate. Okay, so what I mean by that is, let's say I have an xy axis, and I start an angle right here. That's its one side. And then I take that angle and I have it centered right there, and I pull that angle and start rotating it up. Okay, and then I stop it right there. It's like I started here, stopped there. This would be its initial side, this would be its terminal side, and then it forms this angle, which I call theta. Okay. So standard position, we're going to assume that we're going to start right here for all of our angles when we do that. You've seen theta before?
I think so.
In algebra, like x is the most general variable. In terms of angles, the most general variable, we usually use theta. Okay, so theta typically represents an angle. That's why we use the Greek alphabet rather than just x, y, z. Okay, when we're doing this, sometimes we get crazy angles that rotate around. Sometimes they rotate more than once. And then we have, like, it ends up somewhere random. So I might ask you to find a reference angle, and if I ask you to do that, that means it's the closest acute angle between the terminal side and the x-axis. Okay. All right. Let's do some. So we're going to draw the following angles, and then we're going to list their reference angle. Maybe it will help us to think of this, if you want to, think of this in terms of degrees. We're going to just imagine that pi is what again? Okay, but how many degrees is it? 180. Okay, so in my head, I'm thinking pi is 180. So pi halves is what then? Okay, so let's draw this angle. So this angle starts at the x-axis, so I'm going to make its terminal side, or its initial side, the x-axis. And you said half of 180 is, so if I rotated this up, it would stop here. Is there an acute angle made with the x-axis in this case? No, it's a right angle, right? Because it happens to be the same, maybe I'll just highlight it too so you can see it happens to be on there. All right, 11 pi 6. I'm really going to ask you to think this morning, I know. Okay, quick question for you. 11 pi 6 is awfully close, isn't 11 awfully close to 12? Yes. If you had 12 over 6, what would that be? 2 pi. 2 pi is a whole rotation. So would you agree with me, this is a little bit shy of 2 pi? What fraction is it shy of 2 pi? By shy, I mean short of. 1/6. Okay. All right, so what's happening here is I have this angle. It's going to start here. It's going to rotate pi halves. Now it's to pi. Now it's to 3 pi halves. And then you said we're going to go, so it's a 1/6. 6, by the way, is 30 degrees shy of that. So this is its terminal side. Now, mind you, look at my pen here. This started here and it went all the way around to get there. Okay? So it went 11 pi 6 in that counterclockwise direction. What would the reference angle be? The reference angle is, hey, what's the closest angle to the x-axis? What's this angle right here? And you told me it was what? Well, in a 1/6 of pi. Yeah, so we're going to do it in terms of pi. It's a 1/6 pi would be the reference angle. Okay. Let's try for 4 pi thirds. Okay. Here's how I'm going to do this one. How many times does 3 go into 4? 1 and 1/3 times, correct? And if pi is 180, what I'm going to do is I'm going to go a full 180, and then I'm going to do 1/3 of that 180. Are we good with that? Okay. All right, so I start my angle right here. I'm going to go to right there. How far have I gone? I know you're saying 180 in terms of pi. I just went pi. Now I'm going to do 1/3 of this. Can you figure out what 1/3 of 180 is? About isn't it like 60 degrees? But I'm going to, so in my head I'm going about 60 more. It ends up right here. Okay, I just went 1 1/3 pi. I know it's just you're trying to think of it in a different way. So if I went 1 1/3 pi, what's the closest angle with the x-axis? What's that in terms of pi? This is 1 pi. So how far is this? 1/3 pi. So the reference angle here would be 1/3 pi, or pi over 3. Okay. 2.9. What? Okay, this is where you have to think about what is pi about, and most of you learned that. 3.14. So is 2.9 going to be in quadrant 2 or 3 then?
3.
Is it just before pi or just after pi? Before, so that would be in quadrant 2. All right, so this one starts right here. I don't know what, what is it? 2.9 to 3.14, is that point what? Yeah, do I really know what that is? No, like just eyeball it. But I liked what you just said. You know how far apart they are. You subtracted them, right? So I'm going to start here. I'm going to end before I get to 180, okay? That's going to be my terminal side. This is 2.9 radians. And so if you would take 3.14 minus 2.9, that would be the reference angle. And that is 0.24, correct? Radians. Okay, so finding some reference angles. By the way, I'll talk about that in a second. The last thing we're going to do today is do our conversions between radians and degrees, and hopefully this makes sense based on what we were just talking about. We already said that pi radians is equal to how many degrees? 180. Okay, so for today, if you have degrees and you want to go to radians, so you have something in degree measure and you want to convert it to radians, you're going to multiply by pi over 180. If you have radians and you want to go to degrees, you're going to multiply by 180 over pi. Okay, so I have 200 degrees. This is a degree measure. I want to convert it to radians. What am I going to multiply by? Yep. Now, here's what I'm going to tell you guys. For these, if I say to leave them exact, which I would like you to in this case, what you're going to do is you're going to leave pi in your answer. And you're going to leave this value as a reduced fraction. So all I mean by that is, this is 200 over 180 pi. Do you first of all notice that this is divisible by 10? Okay. Just going to do some reducing of fractions in my head. Now I have 20 over 18. Aren't those both divisible by 2? What can I reduce that to? This is 10 over 9 pi. Okay. This one, 7 pi over 8. Now, here's the deal, guys. If there's pi in there, that's awesome because the pi's are going to cancel. If there's not pi in there and you're asked to do converting today, please don't use 3.14. Please use the pi button on your calculator because it's more exact. Okay? But in this case, they're going to cancel. I have radians, I want degrees, so I have 7 pi over 8, not 18, I don't know where that came from. I multiply by 180 over pi. Do you notice the pi on top and bottom cancel? So we're going to do 7 times 180 over 8. What do we get for that? 157 point what?